In the early days of spaceflight, rockets were disposable, engineering marvels built for single use, discarded after just a few minutes of flight. They were powerful, expensive, and ultimately wasteful. But in 2010, that paradigm began to shift. With the launch of a sleek, white rocket from Cape Canaveral, SpaceX, a private company led by Elon Musk, introduced the Falcon 9. At first glance, it looked like just another launch vehicle. But under the surface, it carried a vision far more ambitious: to make spaceflight routine, affordable, and reusable. Today, the Falcon 9 is the most launched, landed, and reflown rocket in the world, a workhorse that has reshaped the economics and expectations of space access. But what exactly makes the Falcon 9 so revolutionary? Let's explore the technology, strategy, and philosophy behind the rocket that changed everything. The Falcon 9 is named after the Millennium Falcon from Star Wars and its 9 Merlin engines that power the first stage. It stands over 70 meters tall, nearly as tall as a 20-story building, and can deliver over 22,000 kilograms of payload to low Earth orbit. But it wasn't just built to be powerful. It was built to be smart. Unlike traditional rockets, which were often customized per mission, the Falcon 9 was designed with modularity and scalability in mind. Its engines are nearly identical, simplifying manufacturing and maintenance. Its stages are constructed from aluminum-lithium alloy, striking a balance between strength and weight. From the start, SpaceX focused on streamlined production, building as many components in-house as possible. This vertical integration allowed the company to move faster, innovate more freely, and dramatically cut costs compared to traditional aerospace giants. The Falcon 9 isn't just a rocket. It's a system designed from the ground up to make spaceflight more like commercial aviation: repeatable, cost-effective, and dependable. Perhaps the Falcon 9's most radical innovation, and the one that truly separates it from previous rockets, is its reusability. Before SpaceX, the idea of landing a rocket stage after launch was considered science fiction. But in 2015, everything changed. After delivering its payload into orbit, the Falcon 9's first stage turned around, re-entered Earth's atmosphere, and performed a controlled landing, touching down vertically on a drone ship in the middle of the ocean. This was no small feat. It required real-time engine reignitions, complex aerodynamic control, and pinpoint precision, all while traveling at hypersonic speeds. The implications were staggering. By recovering and reusing the first stage, the most expensive part of the rocket, SpaceX could lower launch costs by tens of millions of dollars. Suddenly, sending cargo, satellites, or even humans into orbit no longer required building a new rocket each time. Since then, some Falcon 9 boosters have been reused 15 times or more, proving not only that reusability is possible, but that it's practical, reliable, and economically transformative. This single innovation has forced the entire aerospace industry to rethink its approach to launch systems. For decades, launching to space was the realm of governments and billion-dollar budgets. But Falcon 9 has made access to orbit cheaper than ever before. Traditional expendable rockets often cost $150 to $400 million per launch. SpaceX has slashed that to $67 million, and even less when using a previously flown booster. In some cases, launches can cost as little as $30 million when ride-sharing multiple payloads. This pricing disruption has opened the doors to an entirely new generation of customers. Small startups, universities, emerging space nations, all now have access to orbit. Satellite constellations like Starlink, Earth observation networks, commercial space stations, and deep space probes have all benefited from Falcon 9's affordability. But more than just cost, the Falcon 9 has made launch availability more reliable and frequent. With over 200 successful launches, rapid turnaround times, and a growing fleet of reusable boosters, SpaceX has created the first commercial launch cadence that rivals or exceeds even government space agencies. The ripple effects of Falcon 9's success are being felt around the world. National space programs have taken notice. The European Space Agency, United Launch Alliance, Roscosmos, and others are now developing their own reusable systems. China's space sector is rapidly adapting. New space companies around the globe are emerging, spurred on by the reduced barrier to entry. Launches that once took years to schedule now happen every few days. The dream of a global space economy, where data, communication, Earth monitoring, and tourism operate seamlessly in orbit, is suddenly real. And none of it would have been possible without the reliability, affordability, and vision of Falcon 9. This isn't just about one rocket. It's about changing the trajectory of humanity's relationship with space. The Falcon 9 didn't stop at cargo. In 2020, it became the first privately built and operated rocket to launch astronauts into orbit, ending nearly a decade of NASA's reliance on Russian Soyuz spacecraft. The mission, known as Demo 2, marked a new chapter in human spaceflight, one where the private sector plays a central role in transporting people beyond Earth. Since then, Falcon 9 has carried NASA astronauts, private citizens, and international partners to the International Space Station aboard the Crew Dragon spacecraft. But it's not just about getting to orbit. SpaceX's long-term vision, including future missions to the Moon and Mars, depends on the experience and infrastructure being built now with Falcon 9. Every launch, every re-entry, every landing adds to the growing library of data that will one day support interplanetary travel. Falcon 9 is more than a rocket. It's a stepping stone toward a multi-planetary species. The Falcon 9's success lies not only in vision, but in engineering. Its Merlin engines, fueled by RP-1 kerosene and liquid oxygen, are designed for high thrust, deep throttling, and reliable relights, critical for both launch and landing. The rocket's Octaweb engine configuration simplifies structure and improves stability. Advanced software systems handle autonomous flight, aborts, and landings, with thousands of simulations and real-time adjustments made every second. The rocket's interstage, grid fins, and cold gas thrusters allow for aerodynamic control during descent, guiding the booster back to a precise landing zone. Every piece of hardware, from heat shields to fairing recovery systems, reflects a relentless pursuit of efficiency, redundancy, and improvement. Unlike traditional government contracts, SpaceX's iterative approach allows them to test, fail, learn, and redesign rapidly, and that agility has become one of their greatest strengths. The Falcon 9 didn't just launch payloads, it launched a revolution. It redefined how we think about rockets, about cost, about risk, and about space itself. It proved that reusability isn't just possible, but practical. It turned the private sector into a major spacefaring force, and it made space more accessible than ever before. Today, the rocket stands as a symbol of what can be achieved when bold vision meets relentless engineering. But perhaps its greatest legacy is not in the satellites it launched or the money it saved, but in the future it unlocked. A future where launching to orbit is as routine as flying across the ocean. A future where space isn't just for astronauts, but for all of us. A future where rockets land, refuel, and fly again, just like airplanes. And a future where Earth is not the limit, but just the beginning. The Falcon 9 is not the final destination. It's the rocket that finally gave us a path to go farther.